All right, so far we've talked about trig values for common angles on the unit circle. Today I'm going to take you through trig values of any angle. So let's take a look at what a problem like that might look like. Here it says that we have -3, 4, and it's a point on the terminal side of theta, and it wants you to find all of these trig functions right here. So what I'm going to do is first start off by drawing drawing this right here, -3, 4. Let me grab a graph and we'll do that. We're going to go to -3 and then up 4 and put a point. And if I draw a line going back to the center there, that will be my terminal ray. And so here's my initial side. This thing swings all the way over to right here. We want to know what the sine, cosine, and tangent and the reciprocal ratios of those are for that angle. So what I'm going to do is I'm going to draw a right triangle right there on my reference angle. Remember, the reference angle is the angle formed by that terminal side, and the x-axis, that's an acute angle. So this theta right here. Now I know that this side is -3 and this one is 4. I can figure out the hypotenuse by doing Pythagorean theorem. So 3 squared, or -3 squared, plus 4 squared equals the hypotenuse squared. -3 squared is 9. 4 squared is 16. So I get 25 equals c squared, or c must be equal to 5. So if c equals 5, that's my hypotenuse right there. And now I can quickly go through and write out the sine, cosine, and tangent of these angles. So the sine is going to be the opposite over the hypotenuse. So this is, in this case, it's 4/5. The cosine is the adjacent over the hypotenuse, or -3/5. And then the tangent is the opposite over the adjacent, which is -4/3. So that's those three right there listed out. Now let's figure out the reciprocal ratios. The nice thing about doing the reciprocal ratios when you line them up like this is all you have to do is flip these fractions. So I get 5/4, I get -5/3, and then I get -3/4. Notice something here. Whenever we do the reciprocal ratios, they have the same sign. That comes in handy later on. Okay? Let's take a look at another way we can look at these problems, or at least set it up. And that says this: given the following information, determine which quadrant theta lies in. All right. In case you're pausing the video, there you go. You can pause it and write it down if you want. This one right here says sine is less than 0 and cosine is greater than 0. I want to know which quadrant theta is in. So let's take a look at something here. Remember back when we talked about the unit circle. If you haven't seen my video on that, watch that. We went through all of this mess right here. This is the actual piece of paper from that video and everything we filled out. I think I did it over a couple videos where we did the radian measure in one, and then we did the sine and cosine in another, and then finally we had tangent in another. Then tangent and sine and cosine may have been in the same video, but either way, I'll link it if you want to find it. This unit circle, we said that the y value is your sine. So cosine is x, y value is sine. That's in alphabetical order there. C comes before S. So my cosine here is my x value. Cosine here is a negative value because your x value is negative over here. And my sine is positive as I go up above the x-axis, and it's negative as I go below the x-axis because sine is represented by the y value here. So that's something I can use when I'm looking at something like this. The sine is less than 0. Well, sine on the unit circle is your y value. And so since sine is less than 0, that tells me that I'm either going to be in this quadrant or this quadrant if the sine is negative. Then it says the cosine is greater than 0. That's a fancy way of saying cosine is positive. Well, the cosine is positive when x's values are positive. So that tells me I'm either in this quadrant or quadrant 4 down here. And the only time I get both of them, to match this condition is down in quadrant 4. So my answer here is quadrant 4. And remember, with quadrants, we list this out in Roman numerals. Let's take a look at the next one. It says the secant of theta is less than 0 and the tangent is less than 0. Going back to the unit circle, let's talk about tangent real quickly. Remember that we said these tangent values that I've got listed here in periwinkle, we found these tangent values by taking the slope of these lines. So the slope of the line here is 0. The slope of a vertical line is undefined. The slope of this line is square root of 3. How did I come up with that? Well, I said it's made by this triangle right here. The rise is square root of 3 over 2. The run is 1/2. And so rise over run gives me square root of 3 when you rationalize the denominators. These are the values you get. So you could also put sine over cosine, by the way. So anyway, these are my my tangent values going around here, and I'm using slope. And if you think about slope, it makes it really nice and easy to do the problems I'm doing today, because these three lines right here have a positive slope. So tangent is positive right here in quadrant 1. It's also positive down here in quadrant 3. The slopes of these lines are negative, and the slopes of these lines are negative. So tangent is negative in quadrant 2, and it's negative in quadrant 4. And then, of course, it's 0 on the x-axis and undefined on the y-axis. So that kind of helps out when we're trying to decide where is tangent less than 0. So let's do the same thing we did above and just draw a little x-y-axis right here. And I'm going to say, okay, when is tangent less than 0? That's a fancy way of saying tangent is negative. Well, tangent is negative when the slopes of those lines are negative, which is quadrant 2 and quadrant 4. That's where tangent is negative. Then it says the secant is less than 0. Well, the secant is the reciprocal of which function? Remember, s pairs with c, so secant is the reciprocal of cosine. So we can say 1 over cosine is less than 0. That should be a theta with that. So, you know what? I didn't write theta there. Make sure you put theta or whatever the angle is in there. So the cosine here also is less than 0. If secant is less than 0, so is cosine, because flipping the fraction doesn't flip the sign. And when is cosine less than 0? Well, that's when we have x values that are negative. So we're going to be in quadrant 2 or quadrant 3 here. These are the only two spots where cosine is negative, making secant negative. What do they share? They share quadrant 2. So our answer here is quadrant 2. So in this case, we've got theta in quadrant 2. Let's see if we can put these together and see what we get. So here's a problem. It says, let's suppose the tangent is equal to negative 5/4. And then it says the cosine is greater than 0. Find those 6 trig values there. I'm going to start by graphing this out. Now notice, I'll do 2 different graphs here. I could have a couple different situations. For one, tangent has to be negative 5/4. Well, tangent is the same thing as opposite over adjacent. So the opposite side over the adjacent side must be negative 5/4. That means that, let's see, if we say the opposite side is going to be my y value, the adjacent side is going to be 4, I could go 4 this way, positive 4, and then negative 5. 1, 2, 3, 4, 5, and make my line like this. Now keep something in mind, I'm ignoring the second restriction right now that cosine must be greater than 0, and just show you why we need that restriction. So I could have this triangle right here. And with this triangle, this side is negative 5, this side is positive 4, and so the tangent of theta right here equals negative 5 over 4, and we can figure out our stuff from there. The other triangle I could make looks like this. I could say, what if we made the 4 negative? And we go 1, 2, 3, 4 this way, and then up a positive 5. 2, 4, 5. Call this theta. This side is 5. This side is negative 4. Let's do our opposite over adjacent. We get the tangent of theta equals the opposite side 5 over negative 4. Notice both of these will make the tangent equal to negative 5/4. However, your cosine over here is going to be negative. Your cosine here is going to be positive. Your sine on the green one is going to be positive, but your sine on the blue one is going to be negative. So it's important that we pay attention to that second restriction, and that's why we have that second restriction there. It says not only is tangent negative, but cosine is positive. And so when is cosine positive? Cosine is positive when your x values are positive, so that would be quadrant 4 right here. So I'm not going to use the green triangle in this. I'm going to use the blue one. Now we do need to figure out the hypotenuse, and I will say that for our problems here, the hypotenuse is always going to be positive. So you never have to worry about making the hypotenuse negative. So I'm going to take and use the Pythagorean theorem to figure out the hypotenuse. So 4 squared plus a negative 5 squared must equal the hypotenuse squared. 4 squared is 16, negative 5 squared is 25, and that equals the hypotenuse squared. 16 plus 25 gives me 41, and square rooting both sides, I get c equal to the square root of 41. And now from there, I can go through and write up my sine, my cosine, and my tangent values. So the sine is opposite over hypotenuse. That is going to be negative 5 over square root of 41. For something like this, I don't care that if you rationalize or don't rationalize the denominator. We can leave it like that. The cosine of theta is the adjacent over the hypotenuse. So it's going to be 4 over the square root of 41. And then the tangent of theta equals opposite over adjacent, which is negative 5/4. Even though they gave that to me, I like to go through and pretend like I don't know it, just so I can check and say, yep, that matches up with what's given. And then I can check and say, it also said that cosine is positive, and that matches up there also. So that's all good. Now, to figure out the others, I'm just going to take the reciprocals. So flipping this, I get square root of 41 over 5, and make sure it stays negative. Flipping this one, I get square root of 41 over 4. And flipping this one, I get 4/5, and don't forget it was negative, so we need to put the negative there. Okay, so you can kind of zoom out, you can kind of see the whole problem there. All right. And that pretty much wraps it up for what I want to do in this lesson. Now, I've got a bunch of example problems, and I might make another video kind of taking you through that. If not, I'll see you in class, and we'll do examples in class, okay? Let me know if you have any questions. Thanks for watching, and I hope you're having a great day.